With present value is an interesting one. We've got future value. Present value just includes repayment of loans, bonds, mortgages, houses. Bonds and mortgages is simply you being given money by the bank and then you have to pay it over a certain duration. And also present value is used to calculate when you receive your retirement money and you want to calculate how long it will take for you to live off that money, or what in monthly installments can you withdraw from it until the next amount of time. So keywords are loans, bonds, houses, or retirement money that really you receive after working X amount of years. So the present value formula that's important to know, understand, and remember is present value is equals to x1 minus 1 plus I to the power of negative n, square brackets, all divided by our magical interest. So we'll be using this formula to really answer the question of present value. We're given that Lucky and Tandy want to buy a house, which is present value. They're going to get a mortgage for that. That costs $1,200,000 to 100,000. They sell their flat for 240,000, so they can afford to put down a 20% deposit towards the cost of the house, meaning that they're going to take the full loan. They're going to really pay a deposit into it, which will reduce the total amount of loan they need to take from the bank. They need to get a bond, mortgage, or a loan, or the balance. The term of the loan is 30 years and the interest is 7.5% compounded monthly. So what do we know here? They're telling us that, firstly, that they had 240,000, so they can afford 20%. So we need to first calculate, remember that what they're trying to buy costs 1.2 million. So what is 20% of 1.2 million? You just put this to a calculator, see that 20% is 960,000. So really this is what they need finance for the full amount. If you want, instead of calculating that, we know that you can just say 1.2 minus 240,000, you get the same 960,000, because the 240 is the 20%. So this is what actually they need to get from the bank as a form of loan. So, which means that this will be our really key present value. This is what we'll be owing. It should be 960,000. We are told that the interest is 7.5% compounded monthly, which means we need to take the 7.5% divided by 100, which will give us 0.075, because it's compounded monthly, divided by 12. So this is a key element, and that's the key element. And do we know for how long? The term of the loan is 30 years. So we need to calculate how much will the monthly repayment be. And remember, in this equation, monthly consistent repayments are X, and I is the interest, and N is the number of months. So let's calculate that. I'll just really slowly and gently remove that so we have enough space. So the present value will be 960,000. We're looking for the monthly installments. 1 minus 1 plus our interest is 0.075, which is important. It's compounded monthly, so we divide it by 12, minus the duration. They said it's 30 years, but we multiply this 30 by 12 because we want to convert the years, 30 years into months, by multiplying by 12 because it's compounded monthly. If it was a different compounding period, for example, quarterly, we're going to divide by 4, multiply by 4. If it was semi-annually, it was going to be 2, divided by 2, multiply by 2. Divide that by interest 0.75 by 12. And quarterly, I said 4, quarterly is 3, because there are 3 quarters in 12. Or how to calculate that, just say 12 divided by 4, it's 4 12. So calculate x now because x is our unknown value. How do we calculate our x? This is what we are looking for. Or briefly, just go back to the compounding period. If it's annually, so as to clarify the chain of thought. Annually means 1, then semi-annually, this means twice a year. In that, if it's annually, divide by 1, semi-annually you divide by 2, and if it's quarterly means how many quarters in 1. It'll be 3 times a year. And then if it's monthly, how many months are in a year? 8, 12. So these are the compounding periods I'm referring to. So let's continue. So we need to solve for x, and to solve for x, we just need to really cross multiply. And how do we go about that cross multiplication? It will be 960,000 multiplied by our interest, which is 0,075, or divided by 12. And then we'll be left with x square brackets 1 minus 1 plus 0,075 divided by 12 to the power of minus 30 times minus 12. So if you want, you can write it as is, or if you want, you can just punch it into the calculator, and then you'll see what answer you get from that. So we can leave it as negative 30 times 12. Square brackets, remember, we're trying to solve for x. So we can divide both sides by what's in the square brackets, which is 1 minus 1 plus 0,075, all divided by 12, the power of negative 30 times 12. Divide both sides. And the reason we're dividing both sides by it, so that we cancel off what's on the right hand side, minus 30 times 12. So this will cancel that, and you're left with x is equals to 960,000 times 0,075, all divided by 12, all divided by 1 plus 0,075, all divided by 12, the power of negative 30 times 12. And if you patiently put this into the calculator, what I'm getting is 6,712,46. 6,712 will be the monthly repayments that Lucky and Thandi will be paying towards their loan of 960,000. And that'll be the first part of the question. Let's go back to the second part of the question. And financial maths tends to be a bit tedious at times, so you just need to have the patience for it and the accuracy. So the total payments then, remember that they paid a deposit of 240,000 plus, remember they're paying the loan repayment of 30 years, but we have to convert this 30 years into months by multiplied by 12. So this duration, what are they actually paying? They're paying 6,712, or 6 is the one we really calculated then. So this is the monthly repayment they will be paying it for, but they will be paying it over a duration of 30 years, but years converted into months, it's 12. That's why I'm saying 30 times 12, which will be the number of months they're paying times the 6,712,46 plus the deposit they would have paid, which amounts to a total of 2,656,800. No, I didn't write that correctly. 2,656,485 from the calculator. That's what they're gonna pay. Then we also need to subtract the total, the 1.2 million. Remember, the interest that they're gonna pay is this total amount minus what the loan amount that they were given. So what's the loan amount they were given? It's 1.2 million. So the interest that's payable will be 2.6 million minus the 1.2 million, which means the total interest that they're going to pay is 1.455,485,60, which means Lucky and Thandi will pay the interest 1,456,485,60 as the interest on their total mortgage value plus their deposit. The mortgage value was 960 plus the deposit, and the total of their payments is 2.6 million minus the 1.2, which means what they're going to pay is 1.4 million, which is a lot of money.